All right, we're going to learn the difference or clarify the difference between prime numbers and composite numbers. So a prime number is a number that has as its factors only 1 and itself. That makes it prime. So any number that can be divided by anything else besides 1 is not prime. So the prime numbers under 20 are these here. That means each of those numbers can't be divided by any other number except 1. A number that has more than 2 factors, which is the vast majority of numbers, is a composite number. So when we try to find the highest common factor and we get the number and 1 and then 2 and something else, that means it's a composite number. So these are special. Numbers 0 and 1 are neither prime nor composite. They are their own thing. Number 2 is prime, and it is the only even prime number. How crazy is that? Every other prime is odd. Yeah. Okay, so state whether each of these numbers is prime or composite. So I'm telling you that 22 is composite, and I know that because, of course, 1 and 22, but also 2 times 11. If I have any other factors, that's going to be composite. 35 is also composite because I know that beyond 1 and 35, I can at least think of 5 times 7. So if there's anything other than 1 in the number, it's composite. 17 is prime, and I'm going to go up and I'm going to check that list. 17 is on the list of prime numbers under 20. So that means there is no whole number factor. I can't multiply 2 by anything to get 17 that's a whole number, or 3 by anything to get 17 that's a whole number, so it's prime. 11, also prime because there's no factors. 9, you think, well, that's probably prime, but I know it's not. I'll check my list. It's not on that list of prime numbers, and I know that it's composite because 3 times 3 will equal 9, and if there's anything besides the number and 1, it's composite. And 5, I'm telling you that is a prime number because primes, there it is, there's no other factor besides 1 that I could multiply to get 5. So I'm going to find the prime factors of 30. Now this is great. So we take the number 30, and then what we're going to do is we're going to kind of create a tree. And there's a number of different ways to do this. So I'll do it a couple different ways, but they will always end up with the same answer. So we're looking for what prime numbers can we find? We reduce all of the factors of 30 to prime numbers. So let's do one way. Here's one of many ways. I know that 2 times 15 gives me 30. So I have the factors of 2 and 15. Now 2 is a prime number, so that's pretty cool. I know that I'm not going to have to do anything with that. I don't have to do 1 times 2 because 1, of course, is a special number. Now 15 is not a prime number. It's a composite of 3 and 5. So the prime factors of 30 are, and I'll do this in ascending order, 2 times 3 times 5. Now if I took 30, maybe I did it a different way. There's a different prime number I could start with. I could start with 3 times 10. These are 2 factors of 30, 3 times 10. 3 is a prime number, and I'm going to circle my prime numbers so I make sure I keep them separate, because once I've got a prime number, I don't need to go any further. But 10, let's see, that is a product of 2 and 5. Yeah, look at that. Well, in fact, if I reordered these, 30 is equal to 2 times 3 times 5. So no matter how I work this out, I'm going to end up finding that the prime factors of any number will come back to exactly what, no matter how you figure it out, will come back to exactly the same numbers. And there's your work.